Jack Feather with the Math Police Department.
Is there any way I can get some coffee? I've been here for 20 hours.
Maybe. But we have a few questions for you first. We have something that we'd like to show you, if you don't mind.
Okay. Blah, blah, blah. My daughter, blah, 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 blah. The Simpsons, blah, blah, blah. Lame joke. Okay, but wait, what's Trig all about?
Right triangles.
That's right. And now I'm going to share with you how an email from this monkey was the inspiration for Albert Einstein's E equals mc squared.
So, was that you?
Is that you, Sam?
In that video?
What now?
Do you have the coffee? Is it on the way? Can I get some coffee?
Was that you in that video? Answer the question.
Okay, yes. Yes, it was me in the video.
Now that we've got that figured out, so you say trigonometry is all about right triangles, right?
Yeah, that's
Right,
right.
Sam?
Yeah.
Yeah, that's right.
Well, then what does it take this?
I ain't talking.
Oh, also not talking to you.
Sam?
Fred,
But, you know, we got ways for people to talk, Sam.
I'm waiting to make you talk.
Oh no! Okay, next stop, I'll talk. Okay. It's like this, officers.
You see, it's all very simple, Detective. Thousands of years ago, mathematicians realized that for any angle in a right triangle, the ratio of the opposite side to the hypotenuse remained the same regardless of the size of the triangle. They called this ratio the sine. For instance, when a 30-degree angle is placed in a right triangle, the ratio of the opposite side to the hypotenuse is 1 to 2, or 1/2. So it is said that the sine of 30 degrees equals 1/2. The triangle could be this small and have an opposite side that's equal to 1 and a hypotenuse that's equal to 2, or it could be much bigger. We could have an opposite side of 25 and a hypotenuse of 50, but still the sine of 30 degrees represents that ratio of 25 to 50, which still reduces to 1/2. This works for any angle that's put in a right triangle, not just 30. I use 30 just because it's easier to remember than many other angles. Eventually, mathematicians noticed they could put these right triangles on the coordinate plane and begin to measure the angle in relation to the x-axis. Therefore, measuring the opposite side over here was like measuring the value of a y-coordinate. It was also discovered that having a hypotenuse of 1 here helped make finding the sine very easy. Since the sine ratio is opposite over hypotenuse, when the hypotenuse is 1, the sine is just the opposite side over 1. So for 30 degrees, the opposite side is a length of 1/2. You'd have a sine of 1/2 over 1. Just like we've shown, the sine of 30 degrees is still 1/2. As the angle with the x-axis increased, the hypotenuse eventually ended up in the second quadrant. To find the ratio of the opposite side to the hypotenuse, you now had to use a reference angle in the second quadrant to form the right triangle. This eventually led to negative values of sine when the hypotenuse was rotated to the third and fourth quadrants, because the opposite side was now a negative y value. See how the sine of 210 degrees is negative 1/2. As this hypotenuse moved around the coordinate grid, a circle was formed. The unit circle. Since the circumference of a circle is equal to 2 times pi times radius, and since it is this hypotenuse that is creating the circle, this hypotenuse of 1, the circle has a radius of 1. So the circumference of this unit circle is 2 times pi times 1, or just 2 pi. This gave mathematicians a new way to measure angles. They could say that rotating an angle all the way around was either 360 degrees or 2 pi. This meant that half a rotation, or 180 degrees, was just pi. 90 degrees was half of a pi. 270 degrees was 1 1/2 pi, or 3 pi over 2. This circle made it easier to recognize there was a pattern to the sine function. Since the sine is the ratio of the opposite side to the hypotenuse, let's watch the value of the opposite side as we rotate the hypotenuse. At first, there's no opposite side at all. But then it begins to increase until we get to 90 degrees, or pi over 2. Once past pi over 2, the opposite side begins to decrease again until it is now completely gone at pi. Once past pi, the opposite side is getting larger, but since it's now below the x-axis, it's getting more and more negative until we get to 270, or 3 pi over 2, where the opposite side is negative 1. Finally, as we finish our rotation towards 360 degrees, or 2 pi, we see the opposite side getting smaller and smaller again until it disappears. As a result of the opposite side growing, shrinking, growing again, then shrinking back to 0, if we were to graph angles along the x-axis and the sine of those angles along the y-axis, we would see this pattern: 0, up to 1, back towards 0, down to negative 1, and then back to 0. I'm pretty sure, Detective, that this shows you how a right triangle can become a wave. Now give me some coffee.
Now can I get my cup of coffee?
Come on, Zane.
Good. Okay.